The problem is the following data gives the results of inspection of 100 items per day for 10 days. Construct a P chart and interpret it. See, for each day 100 items are inspected. On the first day 6 items are found to be defective, and on the second day 8 items are found to be defective. The D values are given. Now D is the number of defectives which follows binomial distribution with parameters n and p bar. P we are estimating it, and is represented as p bar. What is p bar? P bar is d bar by n. P is fraction defective. P is d by n. Then p bar is d bar by n. Expectation of p is expectation of d by n, which is d bar by n. Okay. So let us compute d bar. When you add all these values, you get 61 by, you have 10 values, right? So the answer is 6.1. So p bar is d bar by n. 6.1 divided by n is 100. The sample size is 100. See, each item, each day 100 items are taken. So you get 0.061 as p bar. And see, expectation of p is nothing but your p bar, 0.061. What about variance of p? It is variance of d by n. That is 1 by n square into variance of d. What is d? D is the binomial variate with parameters n and p bar. So its variance is n into p bar into q bar. Okay, one n gets cancelled. So you have p bar into q bar divided by n. What is your p bar? Let us compute here, 0.061, and q bar is 1 minus p bar. 1 minus 0.061, 0.939 divided by n is 100. Okay, so 0.061 into 0.939 divided by 100. So you have 0.0006. Variance of p bar is 0.0006. Okay. Now let us compute p values, because you are going to plot only p values on the graph in p chart. So p values is d by n, 6 divided by 100, 8 divided by 100, 5 divided by 100, 4 divided by 100, here again 4 divided by 100, 5 divided by 100, 6 divided by 100, 7 divided by 100, 8 divided by 100, and 8 divided by 100. Okay. Now see, let us compute the upper control limit. P bar is 0.061 plus 3 into square root of p bar, variance of p bar, that is p bar q bar by n. We have already computed it. So let us compute this value. And lower control limit is 0.061 minus 3 into square root of 0.0006. Okay. 0.061 plus 3 into square root of 0.0006. You get 0.13, and here 0.061 minus 3 into square root of 0.0006. You get negative 0.012, which should be approximated as 0, because the proportion of defectives cannot be a negative value. See, the highest value that is to be plotted is 0.13, and the least value is minus 0.01. And the values of p are 0.06. The least value is 0.04, and the highest value is 0.08. So I should select a scale on the graph which accommodates all these values. So having a look at the data, I think a scale of 0.01 units can be selected. 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.1, okay, 0.11, 0.12, 0.13. See, I keep adding 0.01, right? So I get values like this. I think I can stop because the maximum value I require is 0.13. Okay, right. Now I'm going to represent the p-values on x-axis. That is why I selected this scale. And the lot number, that is the day number here, on one day one lot is considered, and a sample of size 100 is taken from this lot. Okay, right. Now what values are plotted? First of all, let us plot the ECL, LCL and CL. See, the control limit is P bar, which is equal to 0.061. Let me tell you how to count these values. See, the difference here is 0.01. You are dividing that 0.01 into 10 parts. So you get 0.001. So each small line should be counted as 0.001. Okay. And to be more precise, when you add 0.001 to this 0.01, you get 0.011, 0.01213. This is 1519, 0.02. Okay, that is how you should consider. So I have 0.061 as my p value. See, that is control limit value. 0.06, 1 is the next line. 0.06 is this thick line. 1 is the next line, just upon this thick line. So this is your control limit, 0.061. Fine. Now what about the lower control limit? It is 0. It is approximated as 0. And the upper control limit is 0.13. This is 0.13. Yes. Have split lines for upper control limit. Upper control limit is 0.13. Let us start plotting the values. For the first day, see, the p values are plotted. It is 0.06. Second day, 0.08. For the third day, it is 0.05. Then it is 0.04. Then it is, for the fifth, it is again 0.04. See the data here, p values are plotted. Okay. And for the sixth day, it is 0.05. For the seventh day, it is 0.06. For eighth day, it is 0.07. Ninth day, it is 0.08. On 10th day, it is 0.08. Okay. See, all the points in this graph fall between the limits, between the lower control limit and the upper control limit. So, all the points fall within the limits. So, you can say that the process is in control. But see the behavior of the points. See the behavior. The values keep on increasing, right? So this is indicating something. There is an upward trend in the proportion of defectives. It is indicating something. Okay, so you can get an alert from this behavior of the points that there is some disturbance in the process. Okay, and you have stopped here with the 10th sample, and with the 10th sample the curve is flattened. So you again get an indication that you can still take more samples and check out whether this increase is sustained or whether it is coming down. Okay, so this behavior is indicating that there is some disturbance in the process. Otherwise, for the time being, the process is in control. Okay, thank you.